Hi, I'm John Stanton, and we're in our training lab here in Huntsville, Alabama. And today what we'd like to cover with you today is how to diagnose problems on a gas dryer. And specifically, we're going to do gas dryer no heat. A lot of times when a customer calls in, they have a complaint about drying, either no heat from the dryer, or there can be a situation where they are getting heat, but it isn't heating enough. So we've instructed our call center representative to kind of walk through different things with the consumer, make sure the gas is turned on, make sure that the circuit breaker didn't pop in the case of electric dryer. And then we have them check a few things, make sure that the setting that they're using is actually a heat setting, not an airflow setting. And then we have them do a quick test. What we'd have them do is turn on the dryer, and we have them select a heat setting, maybe cotton's a normal, and then start the dryer. And we let them run it for about a minute. And what they do after a minute is they turn off the dryer, open the door, put their hand inside there and see if they feel heat. If they feel heat, they know that the dryer is capable of producing heat. It's very likely that there's a problem with the vent. So the second test that they have them do is, and it's real simple, you can do this yourself, just use a paper towel or similar material. Now what I've got here is, so I don't have to keep on holding this button, but the customers are going to be basically doing the same thing. In this case, they're not going to use a heat setting, so they'll turn on the dryer, they'll select an air dry setting, and then they'll go ahead and start the dryer. Now I have our push button already taped down, so I don't have to keep on holding the push button in, but the customer will have to hold the push button, and then what they'll do is they'll take a paper towel and they'll put it up near the vent. And you can see here it's not even trying to suck that paper towel in there. And it's very important that when the customers do this, of course they have the lint filter in there because we don't want this to get out of hand and suck that paper towel in there. And then what they have them do at that point is they say, we'll go back in the back of the dryer and disconnect the vent. And then try the same thing again and see if the paper towel gets sucked in. So that'll give you an indication of the quality of your vent. At that point, if that seems to be the problem, what they'll do is they'll instruct the customer to go ahead and either clean the vent themselves or have a company come down and clean it for them. So that's when you get involved into the call, because at this point the vent was good. What she's getting is no heat from the dryer. And of course you can do these steps yourself. You can turn on the dryer to a heat cycle, make sure it heats. You can verify the quality of the vent by doing that simple little test there. Now in a no heat gas dryer, we have a few things that can possibly cause it not to heat. We have an igniter, so we'll show you how to check the igniter. We have a gas valve. Gas valve has two solenoids on there. We'll show you how to check those solenoids. It also has a flame detector. We'll show you how to check the flame detector. We also have another component on there that a lot of people sometimes misinterpret what its purpose is there for, and sometimes they don't even associate it with a dryer not heating. And what that is the centrifugal switch on the dryer motor. The centrifugal switch is designed to do two purposes. It keeps the start winding engaged just long enough to get the motor started. At that point, it takes out the start winding and closes another set of contacts, and we call this the heat circuit. And basically the design on this circuit is to make sure that we don't have any type of heat being produced either with a gas or electric dryer unless the motor is turning. Now we have an additional safety on here. We have a broken belt switch that if the belt were to break, it would completely stop the motor. And at that point, you're not going to get any heat either because the centrifugal switch wouldn't be closed at that point. So let's go ahead and show you how to diagnose some of these components on here for the no heat situation. Now what I've done to save time is I've removed the screws on here and I removed the back panel on here. And we'll go to a couple components and we'll show you how to actually check these. So I'm going to put a little towel down here. I just want to make sure I don't scratch this up. Screws have been removed. I'm going to drop this down, and so did my cover on there. Now there's a tech sheet associated with this, so if you want to on your particular model you can refer it to find out where these different connections are. So what we'll first do is some resistance checks. We'll do your gas valves, we'll do your igniter, and we'll also show you the flame detector on here. Now also, one thing that I forgot to mention too is we also have a couple safeties on here. And these safeties are designed never to open. You can have the dryer for the life of the dryer, maybe 10, 20 years, maybe shorter. Those thermostats with a good vent, with good felt seals on the drum, with a good seal on the blower housing without any obstructions down there, should never open. And these two safeties, one of them is called the high limit thermostat, and that one is resettable. It will reset itself. And the other one is the safety. The safety is usually something that has to be manually reset, or it's a one-shot deal. Once it's open, it's gone. So these are two other things that if they do open, it usually indicates that maybe you had a bad vent or bad seals on the dryer. These things will open. It'll also prevent you from getting any heat. Now, as a safety thing, what we'd like you to do is if you find that the safety thermostat has opened, it's a good service practice, and LG strongly recommends that you do this, is you replace not only the safety thermostat but also the high limit thermostat. And the reason behind that is the safety is kind of the last line of defense. That thing failed because the high limit has been tripping so many times that it finally failed. And it's just a protection for the consumer. We want to make sure that eventually down the road, if that safety were to fail, there would be nothing to stop the heat from heating, and so we'd have a dangerous situation. All right, so let's get into checking a few things here. And what I'm going to do is we'll do resistance checks first. I can also show you how to do voltage checks. So what I'll do is we're going to unplug the dryer. And the first thing we'll do over here is we can actually check the coils on our gas valve in one of two locations. I can do it at the main board, or later on what I'll do is I'll take off the front of it and we can actually go down to the gas valve and do it wherever you feel more comfortable. If you don't remember where these wires are located at, once again you can refer to your wiring diagram, include it with the product to make sure that you get the correct wires. Now, to do some of these tests that I'm going to do today is a good voltometer and an amp probe. Amp probe is something that you'll find invaluable when you're checking the gas dryer out. Okay, so what I'm going to do here is let's go ahead and set up this meter so our fine cameraman could actually see what it's recording here. All right, what we've done is we've dropped this down. We've got to our control board, and what we're looking for here is blue 3. So we have a blue connector with 3 wires here. And these are the wires going down to the gas valve solenoids. The red is going to be common, the pink goes to valve 1, and the white goes to valve 2. So red to pink is valve 1, red to white is valve 2. And what we're going to do is actually disconnect this from the main board here. We'll get a better resistance reading. If we do that, we won't be getting any feedback signals. If you want to do it from the back, just be real careful. What you can do is, if you notice here, there are just a little spaces where you can put those little needles through there. Don't put them in between the connectors, because what you'll end up doing is you'll end up expanding those a little bit, and then when you plug it back in again, you'll get a loose connection. The best way to do it is probably, if you can, especially with these little needle tips here, is to kind of work it down from the front. That way you won't damage any of the connectors on there. So what I'm going to do is I'm going to go from red to pink. Now, the normal ohm resistance on a good coil on that is anywhere from about 1,500 ohms to about 2,500 ohms. So over here we've got about, looks like we've got about 1,900 ohms right there. Okay, so that's valve 1. And now we're going to check valve 2. So I'm going to go from red to white in this case. And I should get pretty similar. I got about 1,900 ohms on that one. So what it tells me here is the wiring going down to that gas valve is okay. And each one of the coils associated with that gas valve are also going to be okay. Now later on, what we can also show you is how to do a voltage check on here. And the significance of that is we can also see if the relay that's sending the voltage down to that gas valve is good. And we'll get into that a little bit later. Let's go on to the next component. The next component we want to check is your igniter. If you feel more comfortable, you can also check the igniter by disassembling the dryer, removing the front panel, and you can get down to the igniter. But we can also do it at the main board here. So what I've got over here is this is the relay going down to the igniter. The black one is the common, so that's the L1 circuit. The blue one actually goes to the igniter. Now I'm going to tap it off of yellow 3 here, pin number 2. And this is a signal back to the main board telling it that the flame detector has opened, so it allows gas valve 2 to actually be energized, and with valve 1 and valve 2 open we get gas flow, and at that point the igniter is hot enough because it had opened up the flame detector, and this is just an indication that that process is happening. It's kind of a safety built into it. We don't want the excuse me, the gas valve opening to both of them if we don't have any way of igniting it. So that's why we use that flame detector. So what I'm going to do is once again take this connector and disconnect it, and I'm going to reference it to the blue wire at pin 2 at yellow 3, and I'm going to go to the blue side of this because this is going to that igniter over there, and I should get anywhere from about 100 to about 800 ohms, and that resistance is going to change because that resistance will change depending on the temperature of that igniter. Maybe you had just had that dryer on and that igniter is hot, so we'll get a little different resistance than if we checked it when it was at a colder temperature, like let's say room temperature. And basically what we're looking for is a resistance reading. Like I said, anywhere from 800 to down to 100 is normal. If you get infinite, your igniter's open, and that's where your problem is right there. Now the other thing we can do is we can check our flame detector. Our flame detector, we can go down to the bottom. The flame detector at room temperature should be normally closed. And what we can do is actually go to that flame detector and we can actually see if we've got a closed circuit. Now I can also do this right here. This is room temperature in this room. I can go to a couple connectors on my main board, or I can go down to the bottom and do the same thing. And what I'm looking for is a closed circuit. So in this case, I'm also going to go to yellow 3. I'm going to take this connection, we're going to open this up again and get a better resistance reading, and I'm going to reference it from pin 1 to pin 3. And actually these are signals coming back to the main board, telling it whether or not one of your safeties has opened or telling it whether or not the flame detector has opened. So in this case what I'm going to use is pin number 1, and I'm going to use pin number 2. And what I'm looking for is basically just a closed circuit. Okay. If I got an infinite, then that would tell me that that flame detector, which should normally be closed at room temperature, is in fact open. Okay. Now there's a couple other things we can do here. We can do some voltage checks also. Before we actually go down to the bottom and go ahead and do some of those resistance checks at the bottom, let's show you a couple voltage checks we can do here. And let's show you how we can use our amp probe too. Now what I'm going to do here is we'll go ahead and we'll plug the dryer back in. Okay. Now I'm going to show you the voltage that we get from each of these coils going to our gas valve. Like I said, the pink one is going to go to valve 1 and the white one will go to valve 2. So what we'll do is we'll change this meter to DC voltage. And then we'll go ahead and we'll reference it to the pin 1, which is red wire. And in this case, let's go to the pink wire, which is valve 2. So let's go ahead and we'll turn on our dryer. And we'll select the heat setting on here. And then we'll go ahead and start our dryer. Now, shortly after the motor starts and the centrifugal switch closes, we should get approximately anywhere from about 90 to about 105 volts DC. So we got about 95 volts DC right there. So you can see where the relay in the main board has closed that circuit and is now sending that 90 volts DC down to valve 1. Now let's go to valve 2. Now valve 2 is going to close after the dryer has verified that we have something there that's going to ignite the gas. And what we're looking for is we're looking for the flame detector to open. Once the flame detector open, and just as a rational reasoning of why the flame detector opened, if you look at where the igniter is in very close proximity to the flame detector. As we energize that igniter, it starts to get hot. It generates a tremendous amount of heat. And that heat will warp the little switch inside the flame detector, and that'll open up that flame detector. So that switch that was normally closed will now be open. And so we get a signal back to the dryer saying that, hey, we have an igniter that's hot enough to ignite the gas. Let's open up valve 2. So you can see right now we're energizing valve 2, And valve 2 will stay closed in a normal cycle until the thermistor says, hey, I've reached duct temperature, turn off that, let's stop heating. Or in a case like this where we don't have any gas, when the igniter cools down, that circuit is going to close again, and then the dryer will go ahead and shut the circuit down for the valve 2. And also what I want to do is on this blue wire, let's go ahead and we'll hook up an amp probe, and we'll show you some of the amperage that we're going to get from our igniter. Okay, see, we got about 3.6 volts DC. We don't have any voltage there. Now the igniter has opened, and we have 104 volts coming down to valve 2. Now I don't have the gas turned on, I don't have any heat coming through here, so eventually what you'll see here is this is going to drop out. We're going to try to repeat this process again, so we're going to energize the igniter again when the flame detector closes, because basically when the flame detector opened, I lost my neutral circuit to the igniter, and that process will keep on repeating. In a normal dryer, what would happen is that process would be interrupted once again by temperatures off your duct thermistor. So you can see our igniter right now, we're pulling about 3.5 amps. We don't have voltage down to valve 1. The igniter has stopped because the flame detector is open, and now we have voltage to valve 2. Now remember, valve 1, as soon as the centrifugal switch in the motor circuit closed, that valve will stay closed for the entire cycle now. The only time it would have been interrupted is if we had actually stopped the dryer, or we had hit the stop pause button. So let me kind of wiggle these around. We'll see if we can pick up that voltage on here again. And as you see me kind of fumbling around with those meter leads, because I kind of violated a basic rule here. I just assumed that I was still in a heat cycle. But what happened is, since I didn't have the the gas valve turned on and I didn't have any wet clothes in there, my moisture strips down at the bottom here had told the dryer that basically the clothes were dry, and what it had done is it had gone into a cool down cycle. And that's why I wasn't getting any voltage coming from here.